All right, so if we go back to what we talked about in section 3.1, and I graph these two lines, y equals 2x plus 3, and y equals 3x minus 5. Okay, so you can either, like I said, use Desmos, or if you want to do it by hand, do it by hand. But remember, what we were talking about is that the answer to this system is where these cross. If I click on that point, do I get what we found by hand, 8, 19? Okay, so that's the first type of a substitution. That's usually the easiest, okay, when they're both solved for y, and then you can just set the two parts over here equal each other. All right, that's one example. Now here is the second example that we see, the second type that we see, and this is when they're not both solved for y, okay? You see that top one is, but the bottom one is not, okay? That bottom one has x and y on the same side. Now, you have options. You can, if you wanted to, you could say, okay, well, I'm going to rewrite this as y equals negative 32 minus x. Is that fair? Okay. And then you could take, well, that one there and that one there. Now they are both solved for y, right? And could you just say that 3x and negative 32 minus x are the same thing? Does that make sense? If the y's are the same, right there and right there, then these parts have to be the same. So we'll go ahead and solve it. So that's just like, that's doing one algebraic step to turn it into that first type of equation that we saw in the notes. So now, what would your option be here? What would be maybe the most logical thing here to solve for x? Okay, so add 32. Okay, so let's add x to both sides. That would make, now adding 32 would not be wrong, but adding x probably makes more sense. So that's going to give me, remember that's 1x, so that's going to give us what, 4x equals negative 32, right? Then what do I do to solve for x? Okay, so it gives me x to be negative 8, right? Now, my steps above tell us that it doesn't matter which equation you plug back into to solve for y. It could be any equation throughout the entire problem, whether you started with it or you made it, as long as it incorporates y. So, of these ones that are over here, we've got 3. We got the 2 that we started with, and then this one here that I made. Which one do you want to plug back into to solve for y? Y equals 3x. I think that's probably the most logical. It's the simplest one up there, right? So if I plug in x right there, it would give me y equals 3 times negative 8, and what does that give me? Negative 24. So then I write my solution as negative 8, comma, negative 24. We write it as the x, comma, y, right, as an ordered pair. Okay, so that's one approach that we can do. Okay, now I like to, because I think it's important for us that we see situations that have multiple approaches and maybe see those multiple approaches. Okay, so there's, you know, in this class, and some of these people are online, but there's about 22, 23 people that are taking this class right now. Going through that example that way, there might be 4, 5, 6 people that don't get it that way. Does that make sense? Maybe it's difficult for them that way. So this is what I want to do. I'm going to go through it one more time and using an alternative route and see if we get the same answer. So right here, in this type of equation, or this type of example, if you have a variable solved for, so right now I've got, we say y is solved for in this first equation, right? Y, when I say a variable is solved for, it means it's all by itself and it has a coefficient of 1. So y is solved for, okay? And because we're looking for where these things are the same, that means the y that I see up here has to be the same as the y that I see down there. Does that make sense? Okay. Can I substitute? What do they tell me that y is in this first equation? Isn't the equal sign the word is? So it's saying y is the same thing as 3x, correct? So down here in the second equation where I see y, what can I replace that with? If the first equation tell me y is, I can replace it with 3x. So when I do that, I get x plus now 3x equals negative 32. How many x's does that give me? Gives me 4 x's equals negative 32. Divide by 4, so it gives me that thing I had already, so I know if I divide by 4 again, x to be negative 8. And then we can go through and plug back into either one of these equations, and we'll see that y equals 3 times negative 8, which is negative 24 again. Does that kind of make sense? Okay. I like that type of substitution better than the first two examples we did. When we substitute, this was a substitution of just one thing. Okay, y replaced with just one object, 3x. Let's come down here to this one here. This example, neither of our equations is solved for a variable. But if I go through there, looking at 3y, 4x, negative 2x, or positive 1y, which one of those would be the easiest to get by itself and to have a 1 in front of it? Okay, so when I look at this one, now what variable would you want to get by itself? Get the y by itself. That makes sense, right? So what is the only thing I have to do to get that y by itself? Okay, so you say subtract negative 2, which turns into adding 2x. So I want to add 2x here to make that go away on that side, right? And then I'll add 2x over here. So that's going to turn into the equation y equals 2 plus 2x, right? Is that right? We good? Okay. So now this top equation, I didn't do anything to that yet, so I'm just going to rewrite it over here. 3y plus 4x equals 16. So now that I've got these two equations, now that I have these two equations here, okay, do you see a y right there in that top equation? Can I replace it with what we said y is down here? Does that make sense? So this top one is going to turn into now 3, but now y, and this other equation we said is 2 plus 2x. And then we still have this plus 4x in this equation, and we still have equals 16. The only thing that we have to be aware of there is that now when I'm substituting that, it's two things I'm putting in there for y, 2 plus 2x. So whenever you make a substitution, and I do this even if it's just one thing usually, always substitute with parentheses. So 2 plus 2x, I'm going to put that in parentheses, like right here. And then when I substitute that right here, I'm going to keep those parentheses. Because what does that do then? What does that tell me that I need to do with this 3 if I'm going to try to solve for x in this situation. I need to distribute it, okay? And if you don't put those parentheses there, you might not recognize that. So I'm going to distribute that and get 6. Distribute again, and I get plus 6x. And then we've got plus 4x already there is equal to 16. All right, so what are you going to do next? Combine like terms. Good. So there we've got 10x's. We've got our 6 here is equal to then 16. Now what are you going to do? Subtract 6. 10x is equal to 10. Divide both by 10, and x would be 1, right? Okay. So now here's my question. We can plug back into any one of these equations that we started with or any equation that we created. Okay? So we can either plug back into the yellow one, plug back into the blue one, or plug back into the green one. But keep in mind what we're trying to do. We're trying to find y, right? Which one of those makes most sense to plug x back into so that you can solve for y? Yellow, blue, or green? I would think the green would be the most logical because y is already set up for, right? If I plug that x back in here, I'm going to have y equals 2 plus 2 times x. And then all I have to do is evaluate that, and I get 4, right? Okay. Now, there's nothing wrong with plugging into the other ones. Okay, but if I plug into the other ones, for instance here, I plug in x to be 1 right here. I get negative 2 times 1 plus y equals 2. And now don't you have to add, you've now got to solve for y. So I got to add 2 to both sides, and I get y equals 4. Up here, if I plug in x to be 1, I get 3y plus 4 equals 12. And now you got to do more algebra, right? You got to subtract 4 from both sides, so I get 3y. I'm sorry, it's 16. I don't know why I did that. So I get 16. So now subtract 4 from both sides, I get 3y equals 12. And now divide both sides by 3, and I still get y to be 4. So people always ask me, well, which one do I plug into? It doesn't matter. The only thing that matters in regards to plugging back in is if you can foreshadow a little bit and say, okay, which one's going to be easier to get my y solved for or my y evaluated for. Does that make sense? Okay. I always tell my algebra students and just any of my students, don't be a robot. Don't just learn 6 steps and say, I'm going to do those 6 steps every single time and not think about what is happening or what the implications of my procedures are for the next step. Okay. Because if you do that, you're going to be inefficient. Okay. Always have kind of a plan and always be thinking, okay, I've got my x value. Now I know I need to plug that in to find my y. Take 5 seconds and say, okay, which one of these is best to plug in to find my y? It's this one, and that saves you time. Okay. We're going to check that. We check all of these. Okay, and like I said, I suggest using Desmos. So I go 3y plus 4x equals 16, and negative 2x plus y equals 2. And if we want to see where they intersect, just click on the intersection point, and we get 1, 4. And that's exactly what we came up with by hand, right? Does that make sense? Why don't you guys take a minute here and do example 4 here. See what you come up with there on example 4. All right, so what are you going to do if we've got that equation where y equals x plus 3? What are you going to do with that? What are we going to do with the x plus 3 here? Noah, what do you do with that x plus 3? Where? Okay, So right there, you're going to replace that with x plus 3. So why don't you say that? Why do I have to call on you? Why do I have to call on you? So I'm going to have 2x plus then 2, because of that 2 right there, right? But now because I'm replacing y with multiple things, I'm going to put it in parentheses, and it equals 38, right? So what's the next step? The algebra tell me I have to do right here. What? Anybody? Got to distribute, right? So 2x plus 2x plus 6 equals 38. How many x's you got? 4 x's. And now what? Subtract 6. Shut up. I get 4x equals 32. Oh, so what's the answer? See how I did that, Noah? Noah, what'd you get? That's 8. Yeah. X is 8. You guys get 8? So x is 8. If x is 8, what do I get when I plug it back in up here? 8 and 11. So when I plug back in for y, I put 8 right there. 8 plus 3 gives me y to be 11. So x is 8, y is 11. Shut up. I do the next one. You might get fractions. So, and that's something to work in your homework is that, Math Excel a lot of times is generating like whole number answers, but every once in a while it'll have a fraction. So don't let that throw you off. So y is already solved for, right? So in this top equation, y is x plus 3. So I'm going to come down here and where I see a y, I'm going to replace it with x plus 3. So I got 3x plus 4 times x plus 3 is equal to 7, right? So I'm going to distribute my 4. So we get 3x plus 4x plus 12 is equal to 7, right? How many x's you got here? 7 x's plus 12 is equal to 7, right? Okay, so now 7x. We'll subtract 12 from both sides. 7x equals negative 5. Divide by 7. So x equals negative 5/7, right? That's okay. Leave it that way. That's fine. So now I want to plug that back in. Which one of these equations makes most sense to plug that back in? Top one or bottom one? Top one. So I'm going to go. Okay. So I got x, which is negative 5/7 plus 3 equals y. Now, if I'm going to add those two fractions together, and Desmos will do it for you, but if I'm doing it without a calculator, what does that 3 need to turn into? What do you need to add two fractions together? A common denominator. So is 21 over 7 still 3? And now I can do negative 5 plus 21, so it gives me 16/7. Okay? Now here's my suggestion to you, especially if I do something like negative 5/7, let's see what that is as a decimal. 0.714286. Okay, and think about if my denominator was 3, it'd be a decimal. It goes on forever, and I had to round that, and then my answer wouldn't be exactly the right point. There is an assignment in Math Excel 3.3.2. Have a wonderful 3-day weekend.